All right, cool. So I actually started this earlier, and this is basically what I have so far. So basically, I've defined the lines that are possible in my file. One of which is an input line, which basically corresponds to a line like this one. And so in my little format, um, hang on, this is too loud. Turn this down. Okay, cool. So in this would mean basically we're trying to parse a list out of this thing. And so the first one would be nil, and then the second one would be D. And basically what we're going to do is we're going to lop this D on top of 2, and then basically start placing the other characters underneath it. So this will read NC and then ZMP. And because the first one is an empty, then we don't read any more nils. If you move this D all the way to the column 3, it will literally insert the nils in between. So it should work as a parser. Now, there's like one goofy aspect of my parser. It does not parse these two lines, and it just treats them as input lines for some reason. I don't fully understand why yet. We can fix that at the end if it becomes a problem. It does give you basically, it does give you like these input lines like this. Let me show you. It gives you input lines here, input line, and then it gives you an empty list of characters here. And so basically you can just say, okay, well, any empty input line is just like, don't do anything with it. So it's not a big deal. But it would be nice if we could like have a part, like a type for our sealed class that basically indicates that it was just like a junk line. We could do that later. Okay, so a block is like this. I just called it a block. I think actually I would like to call it, we'll like work through this. This will be a crate. And then we'll work through that. And then like this is an empty crate or something. It's like empty spot. Let's just call it a placeholder because there's like nothing there. And so like you can either have a crate or like a slot. It's called a slot, like a slot for a crate or something. Okay, and then if you want to parse all the crates, then you're gonna parse a slot. Sorry, you're gonna parse a crate, or you're gonna parse a parse placeholder. Slot. I called it. Sorry, slot. Okay, so crates is like a series. Actually, this is crate or slot. I don't need to put that there. Okay, now for this, we're going to chain 1, which basically means like there needs to be at least one of parse crate or slot. And then the second half of this is like white space. So there has to be like one of these things and then input lines. This actually might fail, by the way, and we'll fix that in a second. So previously I had chain here, which was part of the reason I think I was getting the empties. So there's that. And then a move is basically defined as one of these lines. So move 1 from 2 to 3. So this means like move 1 crate from row 2 to row 1. So if I were to actually do that, then this D would end up on top of ZNN. Okay, so that's basically how this works. And so we basically just parse this, and I'm subtracting -1 from the columns because it just makes my life a bit easier when I build these maps. Okay, so then you can just parse an input line or an action, and then you just get them back. So down here, we do that, and then we start folding things. So right now I'm using a mutable map of, but I probably would prefer to not use a mutable map and like fold stuff, but we can fix that later. Right now I know this is working, and the reason I know it's working is that I get this result from the thing. And if we go look at the input, it's like in 0, it's Z and N, right? Z and N, MCD, MCD, and then 2 is P. So 0, 1, 2. So basically, I'm laying this thing on its side. Okay, and what I'm working on now is like dealing with the rest of this stuff. Let me play this because I think this might fail. Yes. What did it do? Why is there like no output? Okay, cool. So it basically has this problem here where we're like unable to parse. So we do need to fix this. So if okay, so parse number line or empty line. So this is like the last possible option, and we're just basically going to throw this away. And we don't really care about this, so I'm just gonna say like object class empty. Oops. So input line or action. Okay. Oh, I think I could just do object like this. Okay. And then if we do that, then this is going to be a parser that's going to essentially return the empty. And we need to like match both of these things. So we can say like it's going to be one of, and it's going to be either like chain 1 integer the separator is just going to be white space. And the other option is just white space. Okay, let's figure out what's going on here. This is just integer white space and white space. Okay, so this is dot separators. I don't really know how to do this. Okay, so I think it's going to be like val parse number line. And this is just okay, I think it's like this. So if we can parse a chain of integers in white space, then we're good. And then this one is like one of parse number line. And then this is like parser. I think like this. Okay, so if we do that, can we parse number line or empty line? And then down here, can we is empty skipping empty line? I'm just gonna put this here for now. Oh, no, we don't really want to do this. We're just gonna like, well, okay, we can do this and then just to ack. Okay. So, what? Oh, maybe I have just too many friends all of a sudden. Okay, so we found 2 empty lines, which is perfect. So we were able to write like a better parser now. So our parser can handle the empty lines and both the crates, the slots, which are just like the empty spots, and we can reproduce our basically a pair of like the initial state and the actions that we need to deal with. So parser is done, and actually it works better now. Okay, next we need to basically create a series of actions that return a new map. So the way we're going to do that is basically take our accumulator, which is the initial state, and then our actions, all of our actions, and then apply them one by one. So to apply an action, we're going to say like a single action is built up of actual multiple actions, which is kind of awkward. But they basically say how many things you need to do. So like how many crates are you going to move, and then from where to where. So this thing's just going to basically take our map and then 0 to whatever number we want to do. And then we're going to move basically 1 crate to a different place. So that's like what we're going to do here. Okay. So to make this happen, I want to println I don't really like, I'm having issues with this right now, so I want to like mess with this. So applying Okay, so something like this is just like, I just want to wrap the apply movement. Maybe we should just call this begin. apply movement. I really like the song. Okay, now that we've like kind of threaded through like our state changes, like I just want to see what the state changes are, then we can basically write our apply function. Okay, so how does this thing work? We need to take a crate from that position. So we're gonna say like we need a crate, and that crate is gonna be basically map.get or default from, and if we don't get anything, then we just want an empty list. Okay, and then like we want to define our new states. So it's like from stack is going to be the like, okay, what does this produce? A T, or it throws a, okay, so you can't do this for sure. So I think what you need to say is like, that's the crate. Oh, sure. Yeah, that's fine. We don't need to let it if we're just passing that through. So we need the last element, that's the crate. And then in this case, we want to get like from, and then drop last one. To stack is map get or default to, and then the default is empty list. And then we want to basically append the crate. Okay. And then basically we need to take our map and we need to override the like to stack and from stack. So I think I was looking this up earlier, and like we can put all. So we're going to say map dot put all. Oh wait, that's a mutable thing. Okay, so due to the key access to elements, plus and minus operators work for maps differently than other collections. Plus returns a map that contains elements of its both operands, a map on the left and a pair, or another map on the right. When the right-hand side operand contains entries with keys present in the left side of the map, the result map contains the entries from the right side. Perfect. So that's exactly what we want. So we're just going to add a map of from, 2 from stack, 2 2 2 stack. Okay, so this is a this is like a that thing. So hmm. But okay. So this crate is that. Okay, so if this is null, then we have a problem. So let's do the following. So if we get a crate, then I want to do this stuff. I don't know, something like this maybe. So this is like or empty. Like there should be a last one based on this. And then this is an empty list plus what am I doing wrong here? There we go. So I need to like deal with its nullness, its nullability. And so to do that, I can do this. So basically this guarantees that I get a crate. And if I get a crate, then it's safe to pop it from the from stack and add it to the to stack. Otherwise, do nothing because there's no crates to get. Maybe. Let's see. All right. So, here's our first step. We're supposed to move. Oh, we kind of have to print our action. Okay, so our first step is to take a D and move it to 0. Is that right? Let's go look. Whoa, that's our input code. So we take as D and move it to 0. Perfect. Okay. In the second step, we're going to move 3 crates from 1 to 3. But again, these are going to happen in a few steps. So first, we take this D and move it there. And then we take the N and move it there. And then we take the Z and move it there. So MC, PD, and Z. PD and Z. Perfect. Next, we do... Okay, so now we're going to move these to the left. So, yep. So C goes to 0, and then M goes on top of it. Okay. And then it says, finally, 1 crate is moved from stack 1 to stack 2. C to M. So it's right there. So here's CM, and then M is going to move over. Yep. And then basically we want the top of each stack as the result. So that's the end result. M, C, well, yeah, and then P, D, and Z. Perfect. Okay, cool. So I wrote this like mutable version of this, and I got it massively wrong. So I'm kind of happy that this is like working. Okay. So now that we have we basically have the part 1 result map. We need to... Oh, well, okay. Actually, this is the part 1... Sorry, this is the input, because this is probably going to be the input for our this is probably going to be the input for the next one as well, and so we're going to do that. And now we're going to say val part 1 result map equals apply. Was it apply actions? Run actions. So we're going to run all of the actions. Let's call this part 1. Run actions part 1. Okay, and then here is going to take the inputs, and the result of this should be a map of int to list a character. And then basically what we want to do is we want to iterate through this in order. So part 1 result map, and then this is going to be like the result, part 1 result. So we need to take the part 1 result map, and we need to, like, for each, and this is going to have the index and the, like, the list of things, and we want to essentially just print, well, we don't even care about the index, I don't think. I think we just want to say access.last. Oops. I don't know what this is going to do, and I also don't know if for each does what I expect it to do. Weird. Okay. Oh, this is not what I want. I want to map. Maybe. Oh, I think I'm running like with some debugging things. So my guess is CMZ, is it actually in order? No, it's not, because it doesn't do the map like in the correct order. So It's probably like a hash map. So how are we going to do this? I don't know if we're like guaranteed to have. We must be guaranteed to have like an end. Um. What if I change it to a list? What does that do? Like, does that actually do it in order or no? Sequence are like not what I was thinking about. Yeah, okay. Um all right. So, what does that imply? I don't know. Um how should I populate this from this data? I could say like I could have a mutable list and like insert at. I don't know what happens if I do that though. Like, what if I do this? I legit have no idea. So actually, this is like a mutable list of car. Okay, and then like I want to say part 1 result map for each index x, and then we want to say like part 1 result how do we mutate? Okay, we can just add index x. Oh, dot last. What does that do? I don't know. Let's find out. Index out of bounds. Yeah, that's kind of what I expected. Um, so I wonder if we should just assume. Okay. I think we need to sort this as a list. Okay, so let's do part 1 result map to list sorted by. So in here we have like an index and the list. So the selector is this. Okay. And then does that work? Okay, let's see. Because if that works, then we can just do map okay, this time we don't need the index. And here we can just say access last. And then I think that gives us like characters or null CMZ. Yeah. And then here we can just like join to string. Is that all I have to do? I assume like if you don't add, oh, that's kind of right. No, I stop and rerun. Not really sure why it's like printing all this stuff. Okay, so I think this is what we need. This is clearly like pointless. So take the inputs and then like make them into the thing you want, which is this. Okay, so part 1. All right, cool. So now we need to go download our input, which is here. We can save this as day5.text. Excuse me. And then we should just be able to run this and hit play. Cool. So there's part 1 done. All right. So as you watch a crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mode was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Mover 9000, it's a Mover 9001. Okay, so the Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from 2 to 1 behaves the same as before. However, the action of moving 3 crates means stay in the same order. Okay, perfect. As both crates are moved from stack 2 to stack 1, they retain their order as well. Perfect. So this is actually really, really easy because of the way I wrote this. We're just going to, instead of implying, I think we just basically can simplify this, because we're now just gonna like for each action we'll just like take the things that we need. So I think here we're basically going to do something similar to this code, where it's like either we are able to get like the things that we need, or we're not. Okay. So here we're going to say action dot from column, and instead of last we want take last action dot amount, and then this is going to give us a crates. Then we're going to say from our accumulator action dot from column, we want to drop last action amount. That's like the end result. Or we're going to action dot to column empty list crates. This is a list, so we don't really need to do that anymore. And then we want to return the accumulator plus a map of action from column, action to column. And last but not least, this needs to be an accumulator. And that should compile. Lovely. So a very similar pipeline to the previous one. But now we're going to run part 2. And we're going to convert that to a list. We're going to sort by the index. We're going to map to the last character, and then we're going to join it to a string, and we're going to print the part 2 result. And hit play. I'm just going to assume it works. It didn't. List is empty. Interesting. So let's switch back to our test.txt and see if this runs. It does, but I'm guessing it's the wrong order. MCD, yes. So, okay. That implies that we would like to do some more stuffs. Okay, so we have an input map, which is exactly the same. That's the P. And then we're going to take the action and we're going to fold over it. We want to look up the from column, and we want to take the last N and then do this. So print crates to move crates. Okay, and then let's just look at this. Okay, so it only moved D. Oh, it's not return anymore. Okay, so I want to move this into a different function so that I can use return, like the quick return. So we're gonna have a function apply action part 2, which is going to take the map, which is a map int list car. And we need to take an action. So action, and we're going to return a map int list car. Okay, and basically we're going to take kind of this code, stick it here, and then we're going to say now, instead of ACK, this is going to become our map. Map. Return. Else map. Like that. And I think this is right. MCD. Perfect. So yeah, that's MCD, which is kind of like what I expected. The reason that failed is that I was like returning way too early. But I do want to short circuit this when the map is working. I suppose what I could do is say, there isn't like, so this is like do the thing. But like I want to say like do this thing or just return the map. I don't know how to do that. So like like null or else. Kotlin null or else. How do I deal with the or else situation? Like if I have a null, I just want to return. Oh, it's the Elvis one. So it can say or map. Yep. And then I think I don't even need run here. I can just like say like this big long thing. So it's like, if I get the thing, then do the thing and return it or give me the map. So I think that this actually doesn't even need return. Yeah, I'm pretty sure that this is still right. And that's like a little nicer. Because we're basically like saying if the result of this thing is null, then use this, which is just like the input, because there was like we couldn't really apply the action at all. I don't know if this is like contextually correct, or maybe technically correct, but I think this looks nicer than the other solution. It's a little less noisy. Okay, and then methinks we can just try this again. Ta-da! Okay, so there's day 5. Done. So I want to do some stuff here because I think we can clean this up a bit. One thing is like we have this like this type a lot. I think we can just use a type alias and call it like stacks. Note there's like no additional type safety here, but it just saves me having to write this all over the place. So like it's just a stacks type, which is kind of nice. Stacks. This is an interesting case where the first part is actually harder than the second part. How often does that happen? So this is a pair of stacks and list of action, and it's going to return a stacks. Oh, I can't close this like that. And this is also a stacks and returns a stacks. Almost done. So this is a stacks. I don't need this run at all. Like this is just like do the thing. That helps. Int. So this is a mutable map here, which I can probably remove, which I would like to. So let's do that next. You can see here we basically just like are doing some goofy puts, but what I would like to be able to do is just take like if we have an input line to do the right thing, basically. we'll take just a map and then just append to it. Okay, another thing we could do is like remove this. So it's basically you have a list of stacks, or no, this is just a stacks. Close to it anyway. Okay, so essentially we have this like final pipeline function, which is like stacks to print stacks or something. Print top of stacks. So you're gonna have a stack, which is a stacks, and this is just gonna be a stack. Well, it's just like this pipeline here. And then we can just say is this like a thing I can do? Oh, okay. It just wants you to do that. I was thinking about like how do I compose them in a slightly different way, but like fine. You don't want me to use let. I won't use let. That makes you happy, then I'm happy. Okay. Simplified that. Well, it's not really simplifying, but just pulling that out into a thing because like that's the only thing we want to do there. Okay. Last but not least, I want to change this from a mutable map to a map. So this is going to be an empty map, and X. Why is this complaining? Okay. So if we have this, so I think this is still a car. Okay. And we want to say like, if we can get that, then we want to prepend the list. So to do that, we need to first, we have it. What is the shape of this? So the character exists, which means we want act. Okay. So it's like, We already have it. It's so confusing to me. So I don't know why I'm having such trouble with it. It's going to be like list of C plus XS. And then we want the act.first index equals that. So we would like add that to it. So it's like act.first plus index to result to act dot second. I imagine that it has no idea how to do this, so like you probably have to like explain what you want to do. So there's no reason to do this, but we could say list of C plus XS. Okay. So otherwise that thing doesn't exist. So we can just like add it. So this is act first plus, wait, what was it? Act plus index list of C. No. Plus index list of C to act dot second. And then that should still work. Okay. Oh, so we just return So it can't be a map. Got to be like for each indexed. But then like actually this doesn't work either. This run is unnecessary. Okay. What's the shape here? Oh, okay. So it's like, okay. Now what? Hello? Okay, so this is the index. This is the inner accumulator. And then we can do it. Okay, it's just like kind of an interesting order, but maybe it's not that weird. It's a little weird, I guess. Sure enough, this blows up. I should just write this as a separate function. Because I think that this is kind of like really horrible. Let's go back to where we were. And like commit the code. And then write a different function. I think we're almost there. Nope. I can't go all the way back. Fun. So this was a mutable map of like this. And then basically we need to fix this. So this was first put index list of C plus, what did I write? Out put plus XS. Okay, now this should still work, I think. Yes, looks correct to me. We can also, okay, so we want to refactor this bit. So first we're going to commit and we're gonna say, well, actually let's reformat all the code. Okay, and then we're going to commit these. Finish initial version day 5. Commit. What's your warning? At experimental coroutines API. Sure. Yeah, I don't care about the to do. Push. Okay, perfect. So now we need to fix this. So we want a function that basically okay, so we're gonna take an input line. So fold input lines, right? And this thing's gonna take a stack. Stacks. And it's going to take a line action, or what is it? Line, what's it called? Input line. Okay. And this basically needs to return basically a stacks. The stack. And okay, so we're going to say remove all of this. And we're going to basically fold input line. It's going to take the accumulator and it's going to take the liner action. This is also just going to take the liner action because we know it's a line. Okay. This is going to fold these and then point to act.second. And this is going to be an empty map of stacks. Stacks? Like that? Is that allowed? Okay. So that's what we're gonna do, and then we just need to fold the input line onto that, and then this like greatly simplifies our code. Holy crap! Why does this do this? Like every time it switches songs, it like puts that back. It's like really annoying, actually. Okay, what's an input line? I don't even remember. I think this is just a list of possibly nullable cars. Okay, so we basically want to do a fold. Okay, like this. So we maybe have a character. I don't really know if there's like a we can just leave it C. I don't really care. And then like if we just need to know when like C is defined. Is this like allowed? Oh, neat. Maybe there's a way to refactor this later, but like we just need to know that C is like a real character. And so if it's null, right, there's nothing we can do. So here's where this matters, because we're gonna have the accumulator, and we want to know, we want to prepend C. Okay. So the new list is going to be list of C plus ACK get or default index empty list ACK plus index to do list. That looks right. That's way cleaner than it was. I wish there was like a get and modify type function. I just don't know how to do that. There's got to be like a nicer way to do this, I feel like. Because like I just don't know what to use here. Because like none of these functions really do what I want them to do. Like I need to get and then like do something. Hey. Oh, go away. Banned. Bye. I was like all excited somebody was gonna talk, and no, just gotta ban someone. No big deal. Okay, so is empty with default any all contains key filter keys flat map 2. What's a destination? C. What's a C? So something called map 2. What's a destination? I don't know what that is. Min by minus none or empty. Also apply. Dax. No. No. Run. Take unless. No. Combine. Get or none. Don't need that. Zips aren't gonna do it. Gosh, there's so many things. Nah, these are just like the rest of the thing. So I don't really know what the idiomatic way to do this is. Like, in Haskell, this is just like a functor. But I don't really know how to do this here. Okay, so let's try like new list. So we're gonna say like ACK of index, right? And then like if we can do that, if we can do that, we have like a list. So then we could say list of C plus it, or list of C. Like, that feels so horrible. Is there like, or I mean, like, it's right, I think. Oh no. That is not right. Oh god, that code is so bad. I think like I want to use a thing just to like show you what it is. So like result prepended. So prepended is a list of character. I feel like this is like spaghetti. And I don't like it, if I'm honest. But there it is. This is better than it was before. Okay. So last but not least, let's remove our print lines because they're completely unnecessary now. Those were just like random debugging. And because of this, we can also get rid of this run because it's just a fold. This is like actually a very similar thing where we can just say or map. And we can get rid of this run. And this to do is actually done because we did the parse numbered line or empty line so that we can deal with this empty situation. Yeah, so that's actually pretty sick. I like the parser a lot. The parser was really fun. And then we just wrote a bunch of folding functions to handle part 1 and part 2. We have like this really ugly null like code that happens like all over the place. But I don't really know how else you would do this because you kind of just have to look up the results. So I don't know. And then like we do the parsing in parallel, but we can't really do the folding in parallel. So we basically just create our inputs by like processing the lines in parallel and then feeding them to a fold that like puts everything together. I don't actually care about this either, so like let's just delete this run and then oh geez, that's weird. And then just say like skip this line. Because we don't really care about the empty lines. And then last but not least, we should be able to run this. And there's that thing. How do I get rid of all these? Ah. I don't need all this stuff. Just like show me the results. Goes a lot faster if you do that too. So yeah, this is a lot of code for this, but I'm pretty happy actually. Okay, cool. So make